Hey guys, in this video we're going to be going over lesson 5.5, which is solving quadratics by factoring. And so in the last lesson, you learned about graphing them, and that method will always work. You can always look at the graph of it to find out where it crosses the x-axis, but there are other methods that you're going to be required to do. And so you probably learned a little bit about factoring in Algebra 1. Hopefully you remember that. But I am going to kind of reteach it, but I'm not going to take days to teach it as you did in Algebra 1. I'm just going to kind of refresh, and hopefully you'll catch on to it. And we'll do some more practice. Actually, the puzzle that goes with this video, I've set it in the schedule so that you're going to be doing it in class if you're an in-person student, and so I'm there to help you and kind of maybe do some more examples. So when we're factoring, two things we want to look at. Number one, always look for a GCF. Sometimes pulling a GCF out first will make it easier to solve. Now next, you need to look to see if there is a number in front of the x squared. When there is not, this is considered the easier method for factoring. So when we want to go to factor, let's look at our steps. So we want to make sure the quadratic is set to 0. Number one, it is. All right, so step 2, we are going to look for two numbers that multiply to be your C value. So we want two numbers that multiply to be 21, but when I add them, I'm going to get negative 10. And so kind of think about what you know about multiplication and adding. And for two numbers to multiply to be a positive, they either both have to be positive numbers or they both have to be negatives. And since what I'm adding to is negative, then both of my numbers are going to be negative. So what two numbers multiply to be 21 and add to be negative 10? Now, if you can't figure this out off the top of your head, start writing all of the ways to get 21. 1 and 21 or 3 and 7. That's it. So I want to figure out, okay, how can I multiply or add? We got multiplying. How can I add to be negative 10? Well, that would be negative 3 and negative 7. So when I factor, I'm going to write x minus 3, x minus 7. So that is the process of factoring, what you probably learned in Algebra 1. But now those factors help us find the x-intercepts. Because my equation is set equal to 0, I'm going to take each factor, x minus 3, and set it equal to 0. X minus 7, set it equal to 0. All right, so then if I solve and I add 3 to both sides, we get x equals 3. And on the other one, if I add 7 to both sides, we get x equals 7. So our two x-intercepts are 3 and 7. All right. Number 2, we're looking for two numbers that multiply to be 15, but when I add them, I get 8. Those numbers are 5 and 3. So when I factor, I'm going to write them x plus 5, x plus 3. And so then I set x plus 5 equal to 0 and x plus 3 equal to 0. Subtracting 5 from both sides gives me x equals negative 5. Subtracting 3 gives me x equals negative 3. Now you may start to think, oh, well, my x-intercepts are always the opposites of these numbers. Like when I factored, I got positive 5 and 3, but my x-intercepts are negative 5 and negative 3. That is only the case when you're factoring without a number in front of the x squared. Once we do some of those other examples, then that's not the case. So don't get in the habit of just writing the opposites. You need to go through the factors and solve. All right, so number 3, we're looking for two numbers that multiply to be negative 18, add to be 3. Think about it. Those would be 6 and negative 3. 6 times negative 3 is negative 18. 6 plus negative 3 is 3. So we have x plus 6 and x minus 3. And that's equal to 0. So I set x plus 6 equal to 0 and x minus 3 equal to 0. Subtracting 6 would give me x equals negative 6. Oops. And subtracting 3 would give me x equals, or not subtracting 3, I need to add 3. X equals positive 3. Number 4, we're looking for two numbers that multiply to be negative 20, but when I add them, I get negative 1. That would be negative 5 and 4. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So when I factor, I have x minus 5 and x plus 4. That's the process of factoring. Set each of those factors equal to 0. So when I solve, I get x equals 5 and x equals negative 4. All right, number 5, notice it's not set equal to 0. And so I need to bring this 80 to the other side, and I'm going to do that by subtracting 80. And I get x squared plus 2x minus 80 equals 0. So I'm looking for two numbers that multiply to be negative 80 and add to be 2. Those numbers would be 10 and negative 8. So when I factor, I get x plus 10 and x minus 8. X plus 10 equals 0. X minus 8 equals 0. So x equals negative 10 and x equals 8. All right, number 6. So I need to subtract x, subtract 4, and that gives us x squared plus 10x plus 25 equals 0. So looking for two numbers that multiply to be 25, add to be 10. That would be 5 and 5. So when I factor, I get x plus 5 x plus 5. X plus 5 equals 0. Now, since I have the same thing, you do not have to write it out twice. You would get the same answer twice. So this is an example where it only has one x-intercept or one solution. The vertex is sitting on the x-axis. So if I subtract 5, I get x equals -5. I know I kind of sped through those a little bit because I'm hoping you kind of remembered that. And if you didn't, maybe you want to go back to the first example or two, maybe slow the speed down so that you can really get that. When we get to these next problems, that's when it's going to get a little harder. So if you remember at the beginning of the video, I said look for a GCF. And number 1 actually has a GCF. Notice I could factor out a 2, leaving me with x squared minus 1x minus 12 equals 0. And now what's left in my parentheses, that's one of the easy methods that we just did. So we don't even have to follow those steps right above us. We can go back to the other method, looking for two numbers that multiply to be -12 and add to be -1. Those numbers would be -4 and 3. So we get x minus 4, x plus 3, and we also need to bring down that 2. Sometimes the GCF that we factor out won't give us another x-intercept, but occasionally it will. If it's just a plain number, it doesn't do anything for us here. But if it had been like, if I would have factored out an x, then it might have helped us. So since it's just a plain number, I don't set it equal to 0 because 2 is not equal to 0. But I do set x minus 4 equal to 0 and x plus 3 equal to 0. So x equals 4 and x equals -3. All right, number 2, this is where it gets a little more challenging. There's a few more steps. So first off, step 1, it is set equal to 0. Step 2 says to multiply your A times C. So A times C is going to be -90. And so now we're going to look for two numbers that multiply to be this -90 and add, they still add to be -13. So try to figure out those two numbers. If you have trouble, then start by just going down to the side and figuring out all the ways that you could multiply to be 90. So like 1 and 90, 2 and 45, 3 and 30. Keep going, 90 divided by 5, we would have 5 and 18. And all of a sudden, I see that 5 and 18, I can combine those to get 13. If I have a -18 and a +5, that gives me -13. So you do not just go put x minus 18, x plus 5. That's not correct. We have more steps to do. So what we do is we bring down the 3x squared, bring down the -30, This middle part, we put the negative 18 with an X and the 5 with an X. So we change that middle part, that negative 13x, we changed it to negative 18x and 5x. And now we do what's called factor by grouping. So we draw a line down the middle and we find the GCF of both sides. We factor by GCF. So on the left side, I can factor out a 3x. And I'm left with x minus 6. On the right side, I can factor out 5, and I'm left with x minus 6. Whenever you factor by grouping, the numbers that are, or what's left in the parentheses, should be the same. If it's not the same, you didn't do it correct. All right. And then what we do is we take the outsides, 3x plus 5, and we take the insides, x minus 6. You only take the insides once. So I don't write x minus 6, x minus 6. And now it looks something like what we had before, where I'm going to set 3x plus 5 equal to 0 and x minus 6 equal to 0. This first one, I can subtract 5 to get 3x equals negative 5. And then dividing by 3 gives me x equals negative 5/3. And then the other one, all I have to do is add 6 to get x equals 6. So this parabola crosses at negative 5/3 and 6. Okay. Number 3, there is no GCF. So let's start out by multiplying A and C. 6 times negative 4 is negative 24. So I'm looking for two numbers that multiply to be negative 24, but add to be 5. Think about it. Try to figure out what those numbers are. They are 8 and negative 3. So I am going to go back to my quadratic, bring down the 6x squared, bring down the negative 4, and then I'm going to put my 8 and negative 3 in the middle. Here's a little thing that I prefer to do. If I have one of them that's negative, I like to write that one first. Negative 3x. And then plus 8x. It doesn't really matter, but I think it's better to do it that way. Okay. Then I'm going to draw my line down the middle, and I'm going to factor by GCF. So on the left side, I'm asking myself, what goes into both 6x squared and 3x? And we should get 3x. And when I factor that out, I'm left with 2x minus 1. On the right side, I can factor out a 4. When I factor out a 4, I'm left with 2x minus 1. So bring those factors down. The outsides, 3x plus 4. The insides, 2x minus 1. And that equals 0. So 3x plus 4 equals 0. And 2x minus 1 equals 0. For the first one, if I subtract 4, I'm left with 3x equals negative 4. And then I divide by 3. X equals negative 4/3. And on the right side, if I add 1, we get 2x equals 1. And then dividing by 2 gives me x equals 1/2. All right, number 4, very last one. We need to get everything on the same side. So if I need to subtract x and subtract 21 from both sides to get 2x squared minus 1x minus 21 equals 0. So my a times c is negative 42. That's 2 times negative 21. And then, so I'm looking for two numbers that multiply to be negative 42, but add to be negative 1. Those two numbers are negative 7 and 6. All right, so I have 2x squared and the minus 21. And in the middle, I'm going to put negative 7x. Make sure you're always putting an x with those. And plus 6x. Draw your line down the middle. And we're going to factor by GCF. So it looks like on the left side, the only thing that they have in common is an x. And I'm left with 2x minus 7. The other side, I could factor out a 3, and I'm left with 2x minus 7. So my factors are x plus 3 and 2x minus 7. Set each of those equal to 0. Oops. X plus 3 equals 0, and 2x minus 7 equals 0. On the first one, all I have to do is subtract 3 to get x equals negative 3. On the other one, I need to first add 7, so 2x equals 7, and then dividing by 2 gives me x equals 7/2. If it's a nice number that's going to end up being just a nice decimal, like 0.5, you could write that as 3.5. That's fine. But if it's like a repeating decimal, then you would need to leave it as a fraction. So in class, I am going to be doing some more factoring examples in person so you can work on that puzzle. But if you have any questions, if you're a MyRock Online student and you have questions, please let me know and I'll do what I can to help you. Have a